Now we're going to learn how to factor trinomials that look something like this one. But I can't lie. When I started teaching, I used to teach the way I was taught. It made sense to some kids, but not to a lot. And then I thought, well, I need to teach it differently. So what is it that's snagging them? And I figured out from looking at their work and talking to them and asking questions that being able to solve little riddles like this, even though this one's easy, what two numbers have a product of 18 and a sum of 11? That's 9 and 2, right? Nobody knew where the 9 and 2 came from in this problem. And you probably still don't see how it's all going to work in. I'm going to show you, but I need your brain to be with me. So your patience is going to have to come into play right now, because I need you to be able to go with me on this little journey. I'm going to give you two numbers, and I want you to tell me the product and the sum. Let me show you what I mean. 5 and 3, multiply them together, you get 15. When you put them together by adding them, you get an 8. The product of 8 and 2 is 16. The sum of 8 and 2 is 10. Pretty easy, right? Well, you know, in algebra, things get more complicated as soon as we hit some negatives. Now, if anytime you want to do these on your own, just press pause. -5 and -3 is a positive 15. Negative times a negative is a positive. But when you add a -5 and a -3, you end up with a -8. -8 times -2, positive 16. -8 plus a -2 is a -10. 5 times 5 is 25. 5 plus 5 is 10. 5 times a -5 is -25. But when you add these two together, you get a 0. This is its own little factoring problem you'll see in a bit. What happens if you use the same numbers but just change the signs? We have positive 4 times a positive 6, that's a positive 24. You add those together, you get a 10. -4 with a -6, and you multiply those, you also get a positive 24. Your brain's going to want to think it's negative, but it's not, it's positive. But when you combine those and add them, there's your -10. 1 times 5 is 5, but 1 plus 5 is 6. 1 times -1 is -1. 1 and -1 is 0. Nobody ever thinks about the ones. They're invisible. Now, this is how you solve these little riddles, and this is going to help you be able to factor. What two numbers have a product of 24 and a sum of 10? I gave you this one on purpose, knowing that you probably already know the answer, but you're going to go through this process. Now I'm giving you the answers, and I want you to tell me what the numbers were that we started with. Okay, so if the top number is positive, that means it was either two positive numbers multiplied together or two negative numbers multiplied together. The bottom is positive. The only way this could be positive is if we use the two positive numbers. So this number will be positive and this number will be positive. This is the thought process that I go through every time I do a factoring problem. All right, so let's make a list of the numbers that we have to consider. Okay, 24, two numbers that multiply to be 24, 1 and 24. When you add those together, you get a 25. What I'm doing here is coming up with all the ways to make this 24 on the top, looking for the 10 to pop up in this column. 2 and 12, add those together, you get a 14. 3 and 8, add those together, you get an 11. 4 and 6, add those together, you get the 10. And you're like, whoa. That's it. I know, but just let me show you what happens if you keep going. 5 doesn't go into 24. There's nothing you can multiply times 5 to get a 24. Then you would go to 6 and 4 again, and that would equal the 10. See, at this point in your list, your factors are just going to repeat. They'll just be flipped. So we're going to go with the 4 and the 6. Now, we're not actually factoring a trinomial yet. This is the tricky thinking part you have to do before you start factoring trinomials. Do it again. What two numbers have a product of 24 and a sum of 11? 24 is going to be our product and our sum is 11. We know that they're going to be both positive. And if we hadn't already done this, we would make this list again. And there's our 3 and our 8. What two numbers have a product of 4 and a sum of 5? Pick this one on purpose because this little guy tends to throw people off. We know they're both positive and somebody's got it right away and other people are going to get stuck. If you get stuck, grab your little cheat sheet. 2 and 2, when we think of 4, 2 and 2 is what we think of. And when you add those together, you get a 4, not a 5. I did this on purpose because a lot of people don't start with the 1. It's 1 and 4, and when you add those together, you're going to get your 5. So here's a big hint. When you're doing this little list to come up with your different factors, always start with a 1 because you're going to forget it. 1, 4. What two numbers have a product of negative 10 and a sum of 3? Okay, things are getting serious now. The product is negative 10 and the sum is 3. This one's a little trickier, right? So let's think about this. In order to get a negative number when you multiply two numbers, it means the signs were different. There was either a positive times a negative or a negative times a positive. It doesn't matter which way you put them. I'm going to have the red be negative here. So grab your little cheat sheet. We have to multiply to be a negative 10, and we'll combine the factors to see what we get. Starting with a 1, we get a 1 times negative 10. When you put those two together, you get a negative 9. Then I make it negative. Negative 1, positive 10, that's going to give me a positive 9. 2 times negative 5, that gives me the negative 3. You can see we're getting there right now. It's going to be the negative 2 and the positive 5. That gets me to the positive 3. So our answers here are negative 2 and positive 5. What two numbers have a product of negative 20 and a sum of 1? Do you want to try this one on your own? Pause it. The top number is negative, so I know I have a negative times a positive. Come up with the factors of negative 20. 1 times negative 20 is negative 19. That's not a 1. And I'm just going to keep going. And everything you can do that's a routine, that's a pattern, is less stuff you have to memorize. You're just knowing you're going 1, 2, negative 2, and a positive 10. That gives me a positive 8. Then we hit the 4 and the negative 5. We're close. So it's going to be a negative 4 and a positive 5. There's my positive 1. Negative 4, positive 5. Try this one. What two numbers have a product of negative 24 and a sum of negative 2? Once again, the product is negative, so I know I have a positive and a negative. Again, it doesn't matter which one you do first. Let's come up with the numbers for negative 24. 1 and negative 24, that's a negative 23. 2 and negative 12 is a negative 14. By now you're probably seeing the pattern that you're looking for numbers that are only 2 apart. 3 and negative 8, that's negative 5. 4 and negative 6, there's the negative 2. Our two numbers here are going to be a positive 4 and a negative 6. Let's go back to that first problem. From the factoring by grouping lesson, I'm going to pull in the boxes, and then we're going to need the x to come up with these numbers. I'm going to add some more steps here. What we just got done practicing is something you do in the middle. How to start. You're going to multiply the 3 and the 6. That's the number that you're going to put in the top of your big X, 18. We're going to take the 11 and just put it in the bottom. Now we need to find two numbers. This is the skill we just practiced. Two numbers that multiply to be 18 but combine to be 11. And those two numbers will be positive, and they're going to go in the sides of our X. So I run the numbers on my little scratch paper. I know everything is positive, so 1 and 18 gives me a 19. A 2 and a 9 gives me the 11. And if you kept going, you'd have 3 and 6. That's a 9. So I know the numbers I want to use are the 2 and the 9. Now what? You learned how to fill in these boxes when we did factoring by grouping. Fill in the first and the last box. So these two boxes we're going to fill in first. The 3x squared goes here and the 6 goes there. Now, the middle box is going to be 2x and 9x because we're rewriting that 11x as 2x plus 9x. Now I want you to factor sideways. So I'm the 3x squared and 2x, I can take out an x. From the 9x and the 6, I can take out a 3. Now we're going to factor up. From the 3x squared and the 9x, I can take out a 3x. I'm factoring these out. From the 2x and the 6, I can take out a 2. I can factor that out. Your next step is just to write your answer, and that's going to be 3x plus 2 times x plus 3. This is how you factor trinomials from beginning to end. You had to learn a few skills in between, but now we're putting them all together like you were learning some sort of a complicated dance. We're going to factor 2x squared plus 17x plus 30, multiply the first and the last. So that is your 2 and your 30. We're going to put that up here. That's 60. Put the middle number in the bottom. Find two numbers that multiply to be the top but combine to be the bottom. To save some time, I did my little list of my factors of 60 off camera. The two numbers that multiply to be 60 but add to be 17 are 5 and 12. Now, that's done. Fill in the first and the last box. 2x squared goes in the first box. 30 goes in the last box. Fill in the middle boxes. Not the 17x, but the numbers that add up to be 17. So the 5x goes here, the 12x goes there. Now we're going to factor to the side. 2x squared and 5x. The largest thing I can factor out of both of those is just 1x. 12x and 30. The largest thing I can factor out of both of those is a 6. Now we're going to factor up. 2x squared and 12x going up. What is the largest number and the largest power of x I can take out? That's going to be a 2x. 5x and 30 would just be the 5. Now the answers are sitting right there and are just waiting for us to write them down. The x plus 6 and the 2x plus 5. All right, let's do it again. Multiply the first number and the last number. The 2 and the negative 9. That's a negative 18. Put the middle number, the 3, down in the bottom. Check. Find two numbers that multiply to be the top but combine to be the bottom. You have a negative. That means you have to have different signs. I have a negative 3 and a positive 6. When I put those two numbers together, they combined to be the positive 3. Now that we found the two numbers that multiply to be negative 18 and combine to be positive 3, we need to start filling in our boxes. Fill in the first box and fill in the last box. Now let's fill in the middle boxes. That's where we use these side-to-side numbers. So I'm going to put the minus 3x here and the plus 6x there. That is done. Now we're going to factor to the side. Looking at the top row, I have 2x squared and a minus 3x. The only thing I can factor out of both of those is an x. The bottom row, 6x and a minus 9, I can take out a 3. Now we're going to factor up. Looking at the first column, what I can take out of both of those is a 2x. And looking at the second column, I'm going to take out a negative 3. Now you have a positive 3 would work too, but these two negatives here are giving me this big hint. Now let's just double check our boxes to make sure it works. 2x times x is 2x squared. 2x times 3 is 6x. X times negative 3 is negative 3x. And 3 times negative 3 is negative 9. If that all works, then you have your solution, and you can now write your answer, 2x minus 3 times x plus 3. I don't start with these because people learn bad habits when you start with the ones that just lead off with the x squared. There's a 1 there. Do it the exact same way. The way I used to teach it, there used to be type 1 trinomials, type 2 trinomials, and then just made it more complicated. It seemed like there were two different ways of doing all these things. And I decided to do the same thing every time. Multiply the first coefficient times the last number. 1 times 80 is 80. That goes up here. And the middle number goes on the bottom. Two numbers that multiply to be the top but combine to be the bottom. It's going to be 8 and 10. Let's fill in the boxes. It doesn't matter which order you do them in. I'm just going to write them in. I know that the first box is going to be 1x squared. And then I have a 10x and an 8x and an 80. Now I'm going to factor to the side. The only thing I can take out of the first row is an x, and the only thing I can take out of this bottom row is an 8. Factor the columns going up. I'm going to take out an x out of both of these. And on this one, I'm going to take out a 10. Double check your boxes. X times x is x squared. X times 10 is 10x. 8 times x is 8x. And 8 times 10 is 80. Write your answer. There's going to be people who are going to probably leave me some comments, but because they're like, well, these are too easy. You can do them in your head. You don't need to do all this amount of work. Yes, I agree. And if you were in my class, I'd be, yeah, go for it. But when people are not sure what they're doing, they like to have a method that works all the time, no matter what. There's your answer. We're going to multiply that 1 times that negative 30 and pop that sucker in the top of our x. Put that 7 in the bottom of the x. Come up with two numbers. I came up with a negative 3 and a 10. When you combine those, you get the 7. So I know this is all working nicely. Now I'm going to fill in my boxes. I have an x squared. I have a minus 3x, 10x, and then I have a positive 7 right there. That's a mistake. Did you catch it? That isn't what's supposed to go there. I actually saw that from putting it in the bottom over here. That's the mistake. What's really supposed to go there is the last number in the trinomial. I may be the only human on the planet who makes that mistake, but just in case there's one other person who does, I do this all the time. I put this bottom number in the last box. I don't know why, but let me show you what happens if you don't catch it. I'm going to factor off the side. I can take an x out of these guys. Now I have a 10x and a 7. There's nothing I can pull out of there, so I'd have to pull out a 1. That's going to happen sometimes because you will have answers like x plus 1. Okay, factoring up. Now I'm here and I can't factor anything out of a -3 and a 7, so what am I putting here? But let's check the math here. X times x is x squared, x times -3 is -3x, x times 1 is not 10x, and 1 times -3 is not 7. That's how you're going to catch your mistakes, and you can go back and fix those. So let's drop all that crap off, do this again. You're supposed to have a -30 in here. Now we pull out the x, and here we're going to pull out a 10. Up here we can take out another x, and here we can take out a -3. Check your math. X times x is x squared, x times -3 is -3x, 10 times x is 10x, and 10 times -3 is -30. That's how you know you did it right. If all the boxes work, which is one of the reasons why I really like the boxes, it's a lot easier to catch mistakes than just a page full of algebra. Special cases. I already popped the little invisible 1 on this one. Just do the same thing. Multiply the 1 times the 36, put it into the top box. Put the middle number in the bottom box. Two numbers that multiply to be a positive 36 but combine to be a 12 are 6 and 6. Okay, this is why this is called a special case. Now we factor the top row, we take out an x, we factor the bottom row, we take out a 6. The top column, we'll take out an x out of those two, and the second column we take out a 6. So our answer is x plus 6 times x plus 6. The reason this is called a special case, it's called a perfect square trinomial. It means you're just going to have the same thing squared. Up to your teacher how they want it written. Most of us like it written like this, but I didn't really care if people wrote it as just x plus 6 times x plus 6. Okay, this little bugger is a special case, and this will be one that'll just stall people out right from the get-go because it's not 3 terms, and you can't like factor a GCF out or anything. So you kind of have to be a little creative here and think about what's not there. What's missing is the term in the middle, the x term. So let's put it in there. There is no x term, so I'm going to put a 0x here and then a -64. Once we have the 3 terms, we can just go through our same procedure here. 1 times -64 is going to be a -64. Now the number that you put in the bottom is that big fat 0. And I did a practice one that's kind of like this, if you remember that, with the 5 and the -5. Same thing happens here, except it's -8 and +8. We go through, put in all the stuff. Now we do the factoring to the side. We'll take out an x. We're going to take out an 8. Factor up. We'll take out an x. Up. We'll take out a -8. If these are both negative, go ahead and take the negative. But double check with your boxes. X times x is x squared. X times -8 is -8x. 8 times x is 8x. And 8 times -8 is -64. Okay, now look at your answer. X plus 8, x minus 8. Boom. This is a big deal. You're going to use this concept where if you multiply the same binomial times itself, but just change the signs so one is positive and one is negative, the middle terms drop out. All right, here's another special case. Let's play. We got the 1x and the 24. These are pretty nice numbers. What's going to happen? I don't know. It's a mystery. Put the -8 in the bottom. I need 2 numbers that multiply to be positive 24, but combine to be negative, which means I need 2 negative numbers. So let me pull my numbers out here. Since I know they have to be 2 negatives, I'm just going to play with the 2 negatives. So -1, -24 gives me a -25. A -2 and a -12 gives me a -14. A -3 and a -8 gives me a -11. -4 and -6 gives me a -10. Nowhere do we have a -8. There's no combination of integers that I can multiply to make this work. So right now, we're going to say not factorable. See you guys next time. Bye.